Okay, welcome to 4670 lab number el trace. My Spanish doesn't work very well. So lab 3. So on lab 3, it is a very complex lab where you're going to do a lot of dynamic routing. And it's going to take up some processing power on your system for GNS3. So what I am going to be looking for in this lab are the config files like I had wanted for the routers in lab 2 and in lab 1, the routers and the switch modules. You can do this in Packet Tracer if you want to, but I'm going to do it in GNS3 so we can capture all the different configuration parameters on these 3 routers. Now, the switches that you use in the lab can be the generic switches that are in GNS3. You don't have to use the switch module of a 3640 or anything crazy like that. You do not have to put in or make servers in this lab. I am not grading the servers in this lab. Okay? So don't build this elaborate lab infrastructure and think of, oh my gosh, how am I going to turn this in? It's, 100 gigabytes or more in space, right? Because I don't want any servers or anything like that. Now, if you want to put servers in and you attach it for testing purposes and everything else, feel free. All right? I encourage you to do that if you can. All right? But what I'm going to be focused on primarily are the three routers, their configs, and actually I could say the fourth router up here, the ISP router. We're going to make it too. So let's go ahead and get started by launching GNS3. And we're going to create a new project. And I'm going to use the 7200 series for all of these routers. Okay. So new project. Lab 3. There we go. Okay, so I'm just going to come up here and find my 7200 and start plopping routers over here. 2. 3, and I'm going to have one up here that's going to be my ISP. Okay. Alright, so from here I'm going to grab a couple of different switches. Just the generic Ethernet switch will be just fine. I'll put one in the middle, and then one below switch 2 and one below switch 3. Okay. All right. All right, and from here, I believe I have the connections all laid out. It's kind of hard to see. Let me zoom in here a little bit. But if you look at the connections, it'll say Fast Ethernet 1. You can interchange Fast Ethernet with Gig Ethernet. Okay, that's fine. This doesn't necessarily have to be a serial connection. This is an Ethernet connection, but you'll need to make it a crossover connection. So here's how we do that. So it's gig 01 to gig 00 cable, gig 1 to gig 1, that's fine.
Do we have to put in who our ISP provider is?
Nope. 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 Yeah. It looks like that might be a problem. It might not detect it. So if that doesn't work, you can always put in another switch here.
Should it become green automatically even though it's not running, Professor?
No, it doesn't.
Oh, okay.
So we can just ISP switch. Now we can connect this up.
Oh, well, so you have a switch in between.
Yeah. So I'm just putting, so I'm going to put gig 1, gig 1, and gig 1, and gig 2, and gig 2. That way I'll keep everything kind of straight in my mind. Now don't worry about it. If you mess up the numbering, I'll figure it out. Okay, don't worry. I'm not going to dock you for that. All right, so let's go ahead and start spooling these things up and watch our processor get crushed.
All right, great.
Yeah. All right, so what I suggest you do for this lab and for any lab, read all the way through it, because I have a misleading instruction in this one. I'm going to give you a heads up. Okay? So, lab tasks. Configure the routers and switches with the host names depicted in the diagram. Configure the routers and switches with the IP addressings depicted in the diagram. Configure the routing protocol domains according to the diagram. Ensure you have 100% connectivity between all routed networks. Note that route redistribution will be required to complete this task. Full connectivity is validated when you can ping to these different places. Okay? On R1, configure a static default route. On R1 to the ISP, on R1, configure and apply an access control list with preventing RFC 1918 networks from being sent out to the internet. Number 6, re-IP the core transport network from this, which is what it was in the diagram, see, to this. Well, we can skip this step if we just do it outright. Make sense? We can skip this step if we just do it from the word go, from, number 2. So we're going to keep that in mind. We're going to set up static NAT for all of our servers. We're going to set up a port address translation, an overload statement, if you will. We're going to configure a DHCP server on R3. We're going to set up AAA on all the routers, 1, 2, and 3, as if it were homing to the ACS AD server, this IP address, with a pre-shared key of Cisco 123, or radius key of Cisco 123. We're going to create and apply an access control list on R1 using the information below. So these are our allowable services. We're going to create an access control list on R3 using these services. So we have multiple ACLs we're putting in the environment. And then we're going to, last but not least, we're going to configure area-wide authentication within OSPF. Okay, so this is to prevent a rogue router from joining your domain and capturing your routing tables. So the hardest part of this is just getting everything set up. So what I suggest you do is, now that we know this is going to be a /29 and not a /25, let's just start opening up these devices one at a time. So let's go into the console. And we can take a look at what we have to do. So we know that this was Fast Ethernet 00, which is the connected interface. So int f00 IP add 201.68.109.97 30-bit. And don't forget, in GNS3 you got to turn everything on with the no shut command. Okay? Now, also in the ISP, if you want to ensure that you can route everything, the only thing you need to do is create a static route for this IP scheme, 201.68.109.128.
When you say static, meaning it's what specifically?
What is a static route? Is that what the question is?
I guess, yeah.
A static route is a specific route to a specific network. Okay? And we have to put in what our gateway is here, which is going to be the next hop, which will be the .98 on R1. All right, and that's about all you have to do for the ISP. Now, you do need to harden the ISP as well. So, I'm going to skip over this because, you know, we need to have our HTTP engines. Oh, they already are turned off. Nice. You know, we need to lock down our aux ports, things of that nature. Okay, so you're still on the hook for that in the ISP router as well. All right, so that's it for the ISP router. Let's go ahead and move on to R1. So for R1, our fast Ethernet interface goes to our ISP. So we have to get an IP and address of 201.68.109.98. It's a 30-bit mask. And turn it on. All right. And if you remember from reading in the directions, we have to configure a static default route to the ISP router. So, we know what that ISP router is. Its IP is 201.68.109.97. And a default route is an all zeros route, right? IP route. Okay, so there's 7-8 points right there. All right, we also need to configure gig 10, which is attached to switch 1, which is in the OSPF domain. So its IP address is going to be 201.68.109.129. But remember, our network changed from a /25 to a /29. So our subnet mask would be what? 255.255.255. Huh? Nope, that's a /25. Remember, later on I pointed out we changed it to a /29. So what's the subnet mask for a /29? 255.255.248. And remember to turn it on. Okay? Now, we also need to start creating this domain down here, this OSPF domain. So to get into the OSPF engine, we've got to start it with the router OSPF, okay, and then the ID, the process ID 100. All right, you see the prompt changes to config-router. All right, here all we're going to do is tell it what network is in what area. So there's only one network in one area for R1, and that is at 201.68.109.128, and here we have to do a wildcard mask like an ACL, not a subnet mask. So what's the inverse of 255.255.255.248?
0.28.
No. 0.0.0. You're still stuck on a /25, not a /29. 7. 255 minus 248 equals 7. Okay, and then what area it's in area 0. All right, and that's all we're going to do for R1 for right now. So we're going to go on to R2. And with R2, we're going to configure its gig 1 and its gig 2 interfaces. G1/0. He's 130. Again, 29-bit subnet mask. Turn it on. And gig 20 is tied to switch 2. So we're going to do int g2/0 and IP add 192.168.50.1, and that's a class C. Okay, that's where I got this from. All right, and we got to turn it on. Now, we need to go into and start the OSPF process as well as an EIGRP process with Autonomous System 25. So let's do OSPF first. Router, OSPF 100, network 201.68.109.128, and it's in area 0. Same thing that we did for R1. All right, you'll see a negotiation happen here in a second. There it is. Okay, it's made an adjacency between R1 and R2. So next on R2, we're going to exit out of OSPF, and then we're going to go into router EIGRP 25, Autonomous System 25. And here we're going to put in the network 192.168.50.0. Again, it's looking for wildcard bits. This one's easy. It's an inverse of a class C. There's no area for EIGRP, so just hit enter. Nothing else needs to be done. All right. There is one thing I want you to do, though. I want you to kill auto summarization. So auto summarization is basically where the routing protocol will do supernetting on its own. Okay. Now, in most cases, that's okay, but it's not needed because this is the end of the network. This is what we call a stub network because there is nothing else there beyond. All right, so we're going to turn off auto summarization so it doesn't try to do any type of calculation like that when it's doing its routing table. It saves CPU cycles. So the command there is no auto-summary. I'm looking for that. I'm looking for that because that's the best practice. All right. Write early, write often. And let's do a cursory to show run, make sure everything is there. Yep, looks like it. Our interfaces are on. All right, cool. And let's finish this up with R3. Okay, R3. R3 console. All right, int g1/0 faces the OSPF side. IP add 201.68.109. Can't see that. 131. Turn it on. And int 2/0 gig20, sorry, is this OSPF area. So same autonomous system, or excuse me, same process ID 100, is just a different area. Okay. So here we're going to IP add, and this is 172.21.0.1 class C. No shut. And let's go ahead and set up the OSPF. Router OSPF 100 net 201.68.109.128 0.0.0.7 area 0, just like on R1 and R2. You'll see an adjacency that will be made here in a second. I hope. There it is. Okay, good. It made it with both routers, both R1 and R2. And now we're going to add in OSPF 100 area 1 with the network 172.21.0.0. Okay.
Because if there was to be a problem, it wouldn't say loading, it would just say something else.
You wouldn't come up at all.
Oh.
It won't show up.
All right.
All right, area 1. All right. All right, so there's several different ways you can check this. You can do the ping tests like it asks you, but here's the way that I check it. And this is really, really, really fast. And this is the power of using a dynamic routing protocol. I'm going to go back to R1. Okay. And from R1, I'm going to bring up the routing table with the show route command. Show IP route command, excuse me. I'm still stuck in Linux for some reason. Okay. All right, the show IP route command sees that there's my static route. I'm picking up the inner area route from R3. That's good. But what am I missing? What am I missing? I can't see what? I can't see this 192.168 network that's on the back end of R2, can I?
Right.
Remember, in the lab, it says you might have to use, or you will have to use, route redistribution. So to do route redistribution, then we have to go back to R2. All right, we have to go into OSPF. And we have to tell it to pay attention to the EIGRP routes. All right, we do that with the redistribute command. Redistribute EIGRP, and then the AS number, which was 25. And we want it to consider subnet masks for redistribution into OSPF. So we have to put in subnets. That's it. We'll do that. Let's go back to R1. Let's do our show IP route command again. And looky there. Lo and behold, we now see the 192.168.50 network. Okay, so R1 looks great. Let's go back to R2. Let's do the show IP route here. Okay, This looks good. I have my 192.168. It's locally. It's connected. I see the inner area. All right. But what am I not seeing there that I had in R1? What do I not see in R2 that I saw in R1?
Zero, is that all? Is that the first
The
one?
static route, the default route, right? So I don't see that. Well, what should I do there? Should I do a redistribution from R1? Well, let's take a look. Let's go into OSPF router OSPF 100. Do redistribute space question mark. Oh yeah, I can do a redistribute static. Let me cut to the chase. That will not work. That will not work because this is a default route, an all zeros route. If it was a specific static route to a specific network, you would use redistribute static. But because this is a default route, you have to use a different command. All right? And it's not the redistribution command. Is default dash information space originate. Default dash information space originate from the OSPF process. So I'm still in the OSPF process, and I'm going to use this default dash information space originate because I'm originating a route to get pushed, and it's a default route. Now if I go back to R2, I do a show IP route. Looky there. I see that default route. It's not a static route, but I'm getting it via OSPF. Now if I go to R3, I see the same thing. So I have full-blown connectivity to everybody, everywhere. I skipped over the re-IPing because I did it outright. Let's just take stock here real quick where we're at. So all my routers and switches have host names. Yes, one's done. Configure all routers and switches with the IP addresses depicted from the diagram. Done. Configure the routing protocol domains according to the diagram. Ensure you have 100% connectivity. Done. On R1, configure a static default route to your ISP. Ensure the route is seen by all downstream devices. Done. 5. On R1, configure and apply an access control list that will prevent all RFC 1918 networks from being sent out to the internet. On R1, configure and apply an access control list that will prevent all RFC 19 networks. So is that going to be a source IP or the destination IP?
Destination?
No. Source. So if it's a source IP, what can I use as an ACL? Standard or extended? Standard or extended? Standard is correct, because standard only requires that you inspect what? The source IP or source IP network. Okay. So that is going to be on R1.
Oh, I see. Sent out to internet from the, okay.
So I'm just going to do an IP access list 10. Access dash list 10. Deny 10.0.0.0. All right.
So I see you're going to do it for pretty much all the.
Just the RFC19 address spaces. There you go. And then I got to apply it. So where do I want to apply this? Yeah, but where? Which interface?
You said the source.
Probably best to do it here. So the interior interface, which in this case was gig 20. So int g2/0. IP access group 10 in.
I see. So it's going to pretty much take place there.
Right.
So, okay.
So we did the re-IPing, set up NAT as follows on R1. So on R1, we're going to go ahead and exit out of the interface. IP NAT inside source static the inside local IP address, which will be 192.168.50.4 to the global address, which is the public address, 201.68.109.137. Okay. That should work. You can make it extendable if you want. All right. Now just up arrow and finish the other ones. So 10 is going to go to 138. Up arrow 25 to 139. (43 to 140). And 125 to 141. There we go. Now we have to go into the interfaces and do the inside, IP NAT inside, IP NAT outside, right? And that's pretty easy. Int G2/0 is the inside because it faces the OSPF domain. And then the fast Ethernet 00, which faces the ISP, is the outside. Int F0/0. There you go. That's number 7. Number 8 is pretty, we've done that in a previous homework assignment, setting up the PAT. So here, IP NAT source inside source. Instead of a static, though, we're going to do a list because we're going to create another access list for source IPs from the workstation network. Okay, so we need to do that first. So do access list 20 permit 172.21.0.0 class C. That's it. That's all you got to do. Because we're only looking at permitting that network and no others. Now we can go back and do the IP NAT inside source list 20 interface. It's going to go out fast Ethernet 00 because that faces the ISP, and set it to overload. Okay, so that is your PAT statement. You have to set up your list to define your interesting traffic from the workstation network, and then you have to tie it to the interface via the IP NAT inside source list statement. So that is number 8. Number 9, configuring R3 as a DHCP server. Okay, so R9, IP DHCP pool. We're just going to call it workstations. All right, changes it to the DHCP configuration. All right, so it looks like we're going to set it up on the 172.21 network. And we're going to exclude from 1 to 25. Okay, so we can do network 172.21.0.0. Okay, that'll set up the entire network, which is fine. Now, notice I did not say anything about a DNS server or anything else. But if you look at the diagram, I do have a directory service, AD, ACS. That's a directory server. I should make 192.168.50.4 my DNS server. Okay, yeah, or if I wanted to go really all out, give it a public one as well. Okay. Now, to do the exclusion, I have to be outside of the DHCP scope and use the IP DHCP excluded address. From the low to the high. One through 25, and that solves that. So now if I look at a show run here real quick, there's my excluded address, there's my workstations. That looks great. Now we're ready to move on to number 10. All right, we need to set up AAA on R1, 2, and 3. All right, you did that in homework 2. Number 11, create and apply an access control list. You've done this throughout. I grade relatively leniently on the ACLs, but keep this in mind. You're going to have previously natted, so your ACLs need to match a specific address dependent upon what the packet's going to look like when it's coming in the router, depending upon where you're going to place that IP address. All right, you have a couple of different ACLs to write. All right, you have one for 11, you have 2 for 12. All right, 10, 11, and 12 really kind of mess people up. But this is going to separate the A students from the B students from the C students. You've done 10, 11, and 12 already. I'm going to skip over here to number 13. Okay? And we're going to set up OSPF area authentication. All right? So you have to do this in 2 ways. You have to do it in the OSPF area the OSPF router configuration area and on the interface. All right. So here we're going to router OSPF 100. All right, and then we're going to do OSPF sorry, area zero authentication message digest. Okay. And then we have to go into the interface, which in this case is G1/0. And we have to do IP OSPF authentication message digest IP OSPF authentication dash key, and then whatever the key is going to be. In this case, it's going to be Cisco lowercase. So those are the three commands that you got to do on all routers, on the appropriate interface and the appropriate obviously OSPF function. OSPF router OSPF 100 area 0 authentication message digest int G1/0 IP OSPF authentication message digest IP OSPF authentication dash key Cisco. And R3 router OSPF 100 IP OSPF authentication digest IP OSPF authentication dash key Cisco. There we go. So if we look at a show run, we can see we have the IP OSPF authentication and the key, and under the routing process, the area authentication with message digest. That's it. Double check everything. You can do a show IP route. You see I still have all my routes. Same thing with R1. Yep. There they are. Okay. So when everything is done, just do a quick write mem of all your routers. including your ISP router. All right. All right. And it's saved automatically. So I can do a save project as if I want to, but it does a running tally. All right. So I'm going to stop all nodes. Quit GNS3. And then to go and grab the config files, I think it's under Documents.
Not in virtual machines.
No, it's not in virtual machines. I've lost my GNS3. I don't know where it went. I'm looking for a projects menu.
That was the dining down the lips.
I hid it from myself. See, users. Okie dokie. We'll find it. C:\users. There it is. Projects. And there's the lab that I was doing. Project files. Dynamips, and there's my 4 routers. Okay, so I go in here, I go to configs, get the, see the startup. Yep, looks pretty good. What did I forget to put in here? There you go. Don't forget that one, guys. So this is R2.
But did the instructions call for doing the password encryption? You just
I said that up front. It's always got to be done. There's R3. So here's where you can grab and save these as your config for R1, R2, R3, ISP. And email those to me or actually upload them to Blackboard, and that's what I'm looking for, those 4 files. Okay? So that's where you get them. All right, so for that, I'm going to sign off because I'm at almost 50 minutes here. And I'll take questions from the class. So thank you, YouTube, and rewind and replay if you need to.